All right. So for those of you who've been having a little trouble sort of getting a grasp on reliability, let's take another crack at it if we can, and let's review some concepts and then let's see it in a spreadsheet. Maybe that can help. So the basics of reliability is that when we measure something, when we give exams, when we give tests, we're measuring. We're measuring things with our tests. We're measuring knowledge. We're measuring intelligence. And we want those measurements to be as accurate as possible. The ability to measure accurately is the essence of reliability. If our instrument, if our test is reliable, then it means that we should be able to give that test any number of times and the people will get the same score every time they take it. So reliability has in a lot of ways to do with replicability. If we can replicate, if we can give our tests and replicate our results, then we think that our test or our instrument's reliable. So classic test theory starts with what might be a new concept to you, and it may be giving you some trouble, and that is when we get a test score. Let's say you're taking an SAT test. We're going to have two components to what we see. Obviously, the test result that we're looking at is our observed score, our observed test score, what we've actually measured. But that's a test. That's a construct. Someplace, theoretically, we know what the true test score would be for that person, but we might have measurement error involved. In fact, most times we do have some kind of measurement error. So we have two parts of the observed score that contribute to what we finally see, and that is the true or theoretic score that if we could have measured accurately we'd have seen. But then also we've got measurement error. We've got some characteristics that give us the score that we get that really don't relate to the true ability of the student. So mathematically, our observed score equals the true score plus the error. And sort of conceptually, we put this in mathematical terms by doing variance. Remember how we did variance last week? It contributes right into this. So if we take the mean of our concepts, and if we take what we observe, difference it from the mean, and square it, we'll get a sum of squares, and we can average that, and we can get a variance. So basically, we have variance in the observed scores, we have variance in the true scores, and we have variance in the error terms. If this term, this error term, goes to 0, then our observed score is going to be exactly the same as the true score, and that's what we're really after. We want to minimize measurement error. We want this error variance to go away so that the observed equals the true. Sort of conceptually in a box here, the total variance is everything we see. So we take our observations and we get a variance. A portion of that's the error variance. The other portion of it's the true variance. And basically we were trying to make this orange box, the error variance, disappear so that all we have is true variance. If true variance equals observed variance, and we divide one by the other, we're going to get 1, and that's what we're after. So conceptually, the proportion of the observed score that's related to the true score is something that we call the coefficient of reliability, or the reliability coefficient. So mathematically, if we divide the true variance by the observed variance, we're going to get that little indicator. Reliability is the lack of error variance. So if error variance goes away, our reliability goes up, particularly as measured by this reliability coefficient. Correlations, the correlation of reliability, or the index of reliability, is the square root of that reliability coefficient. So that's the correlation between the true and the observed, or the observed and the true. If there's no error, then there's no correlation between the observed scores and the error. Okay? Once again, if there's no measurement error, the true variance equals the observed variance, and the ratio of true to observed is 1. Here it is mathematically. Our reliability coefficient, total variance, true variance divided by observed variance. Different way of expressing it. You don't have to get hung up on it. If this goes to 0, which is what we want, then our reliability coefficient goes to 1. Okay, it's really that simple in terms of concepts. Basically, if our reliability coefficient is 0, all the observed scores are random error, and our test has no meaning, it's not reliable. It's just a mathematical way of expressing it. If the coefficient of reliability goes to 1, there's no measurement error, and the test is fully reliable. And really, there's nothing more to it than that. Let's go take a look at it on the Excel spreadsheet. It's the XLS spreadsheet called Reliability or Reliability 2. So in the lecture notes and infer, suppose we give a test to 6 people. And here's what they get on the test. Here's the observed score for person number 1, 120. The true or actual, right? I could put true in there. That might be a better way to put it, right? So here are the true scores in this column. Here's the error, the difference between what's true and what's observed. And if you look at the cells here, it is the observed minus the true. So here are our errors. They add to 0. Since error is random, they cancel out. So we take our means for both observed and the true, and they have the same mean. So we put the means for our observed in this column, the means for this little box is getting in the way. The means for our true column here, and the means, which are 0, for our errors here. We subtract the mean from the observed. That's our difference or deviance. We square it. We get a sum of squares and divide by the number of observations, which is our variance. Just that simple. Okay, so the variance for observed is 608.33 here. If you want a standard deviation, you can take the square root of your variance. The variance for our true score is in this column with its standard deviation. And here's the variance for our error term. Now, we said that the reliability coefficient is the total, the variance of the total divided by the variance of the observed. And so in this cell, we're going to divide the true variance, 291.67, by the observed variance, and we get 0.48 for our reliability coefficient. We said we could also subtract the error variance divided by the observed. So that would be 316 over 268, and we could subtract that from 1, which is what we've done here, and we come up with the same coefficient for that. We should be able to get that whichever way we do it. Now, how about for our second test? Here's the second test, and here are the scores for the second test that we observe, right? We've tried to improve the test. Here's the true. They're going to be the same as they were before because it's true. And then we're going to subtract to find our errors, how erroneous our score is. The mean of observed is still 105. The mean of actual is still 105. We're going to put those in the mean columns. We're still at 0 for our error term. And this time, we come up with an observed variance of 408.33. We have a true variance, 291.67. That ought to be the same, right? Because it's true scores. And then here's our error variance. And see, it's dropped. We're now down to 116.67. So if we divide 291.67 by 408.33, we're going to get a new reliability coefficient of 0.71. And I mean, is it clear to you we could do the same thing by subtracting the error over the observed? It's rounded it off, but there it is. 0.71. Same result. Okay, last piece of this. Suppose our test is perfect. Suppose our observed scores equal the actual scores. Means 105 again, no errors. So here's observed and the means. And lo and behold, we've got an observed variance of 291.67. We're back to our true again, 291.67. Nothing for error, right? So now what are you going to tell me? If I take this divided by that, I get 1. We have no error. We have a perfect test. The test is reliable. So that's the reliability coefficient, and I think maybe this could help you understand conceptually and in mathematical terms what's going on here in terms of developing the reliability coefficient and what it means. Thanks.